So far in this series, we've covered list views and table views, two of the most common ways to display data in QML. In this final video, we'll round things out with two more view types. First, we'll look at the tree view, which is perfect for hierarchical data like file systems or nested categories. Then we'll explore the object model, a unique model type where the items themselves are visual components, no delegate required. Let's wrap up this series. We will start with a TreeModel component already created and fully functional. Since the TreeModel can only be implemented in C++, we will only be focusing on the QML parts of this application. However, if we take a quick look at the createModelData function of our TreeModel class, we can see it is using data for a contacts application, like what we saw in the previous examples. Moving back to our main.qml file, we can see we already have set up our import statements and created a component which represents the tree model. Since we already have our model set up, the first thing we will do is create a delegate for the tree view. Unlike the other views we have looked at, the tree view has its own delegate component called TreeViewDelegate. So we will create a component with a TreeViewDelegate as its child. We can add required properties inside the TreeViewDelegate which match the roles defined by role names in the model. In this case, those roles are displaying and addition. Displaying will contain the text at the current delegates. Addition is used to modify the current delegate's text. Both properties are managed by the model. Next, we use the background and contentItem properties of the TreeViewDelegate to customize its appearance. We will set the background property to a simple white rectangle. Then we will set the content item to a text component, which has the text stored in the displaying property. With that done, we are ready to create our tree view. So we will add a tree view component and set the model property to the ID of our model and the delegate property to the ID of our delegate. Running the application, we can see we have a tree view with the Doe, Smith, and Wolf families visible. Clicking on the arrows will expand the tree view, revealing all the members of that family. Then expanding further will reveal their age and phone number. Now that we have a functional tree view, the next thing to do is to customize it and make it editable. We will start with some simple customization using the properties of the TreeViewDelegate. The depth property will contain an integer which correlates to the depth of the delegate. Therefore, we can use this property to customize the color based on the depth. We also have the current property that is a Boolean, which is true if the delegate is the current index in the view, so we can use this to modify the border width to indicate to the user what the current index is. Like the table view, we must also define the selectionModel property in the tree view so that the delegate knows which model to use when interacting with the view. Running our application, we can see we have a distinct color used in the delegate based on the depth of the delegate, and when we select an element, we get a border around the current index. The last modification to make will be to make our tree view editable. Like the table view, the tree view uses an editDelegate to handle editing of data. So we will add an editDelegate which will use a text field as its component. We will use the text stored in the displaying property as the initial text. Then when the change is committed, we will simply set the addition property to the text of the text field. We also will need to modify the width of the tree view in case the new text is longer than the previously stored text, so we will add an onEditingChanged signal handler to set a new width. Finally, we need to set editTriggers in the view, which we will set to DoubleTapped so that the editDelegate only appears when an element is DoubleTapped. Running our application, we can see that when we double tap an element, our editDelegate appears, and we can modify the text as we like. If the new text is longer than the original text, the width of the view will change accordingly. That concludes our look at the tree view. Now let's shift to something completely different, the object model, where the model items themselves are visual components. We will start with a mostly empty Qt application, with an additional QML file added to the project called Custom Object, which currently has nothing in it. The first thing we will do is implement this custom object. We will have our custom object be a simple rectangle and text component. We will add two custom properties called ObjectColor and ElementNum. The ObjectColor will be used to define a color for the rectangle, and the ElementNum will hold which element in the model this is, which we will set to be the text of the text component. Next, we will add a MouseArea to the rectangle, which will modify the color of the rectangle based on our interactions with it with the mouse. With that done, our custom object is complete. This is the object which we will use in our object model, so let's move to our main.qml file and implement the object model itself. To do this, we will create an object model type, and inside it we will add 3 instances of our custom object, giving each an object color of light gray and ascending element numbers. With that done, we can add our view. We will use a ListView in this case as it is the simplest to work with, but the object model can be used with any view type. Here we will simply assign the model property to the ID of our object model. We do not need to assign a delegate since the custom object we created already has all the visual information the view needs to be created. So, if we run our application, we can see we have 3 instances of our custom object, labeled element number 1, 2, and 3, and if we hover over or click them, the color changes, providing us with some feedback. Next, let's see how we can dynamically create and add new objects to our object model. To do this, we will add a keys type with an onDigit1 pressed signal handler, where we will implement some code to create a new object. Here we will create a variable called num, which will be equal to the number of items in our model, plus 1 which we will use to set the ElementNum property. Next, we will use the createComponent function to create a new component based on our custom object type, and store this in a temporary variable. Finally, we will append the model with the component using the createObject function, setting the object color to light gray and the ElementNum to our num variable. Running our application, we can see when we press the 1 digit, we create another instance of our custom object and append it to the model. And that brings us to the end of the series. We've covered a lot of ground, from building your first list view with delegates, to customizing and animating it, to setting up editable table views with headers, and finally, exploring the TreeView and ObjectModel. You now have a solid foundation for working with the model view delegate architecture in QML. For more advanced topics such as building C++ models, be sure to check out the full course on Qt Academy. Thanks for watching.